Nye for the process.
Yep.
Yeah.
I think at one of the board meetings, right? Yeah.
Yes. Yes.
Yes.
Yeah. I hate everything song. Yes. Oh, I got to put the phone on stun. Hang on. Whoop.
Oh yeah. Good call.
Yep. I put it in airplane.
I believe we're live. Are we live? Hello, everyone, and welcome. Thank you to Barnes & Noble for having us. My name is Gregory Mone. I'm one of the co-authors of this new book, Bill Nye's Great Big World of Science. Tonight, we got Bill Nye here.
Greetings.
And we also have our fabulous moderator, Brittany Schmidt, a planetary scientist and astrobiologist from Georgia Tech.
Hey, everybody. Nice to be here.
So again, thanks to Barnes & Noble, we're going to be doing about 20 minutes of back and forth. Brittany's going to be the moderator here because she's way more interesting than me. And then we're going to have about 25 minutes of questions at the end. So if you want to put some questions in the chat for Bill Nye or myself or Dr. Schmidt here, that will be great. We're very excited about answering the questions. And so without further ado, I'm going to hand it over to Brittany to get things started here.
Awesome. Well, thanks for inviting me, guys. This is really a thrill, a nice break from my house that I'm coming to you guys from. Yeah, it's really an honor to be here to talk about science and the excitement I think we all share for it, and to hear a little bit more about the book and how you guys decided to write it. So maybe we might start off there for those who haven't been to one of these events before. Maybe Greg or Bill, could you tell us how you got interested in writing this book and why you put it together the way that you did?
Take it, Greg.
Well, we were in a golf cart or something like that, and Bill just turned to me, and we'd written these other books, these novels, Jack and the Geniuses, a series of novels about kids who go on these adventures and solve mysteries using science and technology. And incidentally, there is a character in this one loosely based on Brittany who goes on her own adventures to Antarctica every year. We can get to that later. But Bill turned to me at this one event at the World Science Festival, and he says, Greg, we got to write this big, giant book of science, and you need to help me. So, Bill, you tell me, why the drive? Why did you feel like we needed to?
Well, okay. First of all, I met Greg the way you do at a coffee shop in California. So what you do after that is you go surfing. So I met Greg. Greg by the way, can really surf. I cannot, but he can really surf. And we started on those 3 books, Jack and the Geniuses, that he just referred to. And the idea there is that these young people make the world better with science. And, when you're a kid, what is it you want? You want to live without parents. So Greg and I came up with a way for them to do that. And each of the 3 books has one of Bill's, that's me, one of my big themes: clean water, renewably produced electricity, and then access to the internet or global information, electronic information. Each book has that in the background. So that was a start. But then you get into, well, what's the science behind these science fiction ideas, Bill? What is it you're trying to get across? And so the people at Abrams Publishing said, you guys ought to do a big book. And then when I saw Greg again, I was able to talk him into it, to interest him in the project, because it took a couple of years, you guys, to get, we say in television is all about words and pictures. Well, this book, I'm so proud of it. The way I describe it, it's the book I wanted to write. It has all kinds of pictures and all kinds of words with all kinds of descriptions of scientific phenomena that I think everybody should know about. And I say all the time, we don't want everybody to become a scientist. And I like to joke, believe me, we don't want everybody to become an engineer. That the fashion problems alone would be overwhelming with that. But we do want everybody to be scientifically literate. That is to say, have an understanding of science. And the big thing, we think of science as a body of knowledge there's elements, there's cells with nuclei, there are plants and animals and stars and planets. Okay, but we really want you to get the process. Like, how do we know this about the universe, about the cosmos? How do we know these things? And that's the process of science. So in the book, along with the words and pictures, we have 30 demonstrations, 30 home experiments that you can do. And by the way, I refer to them as demonstrations because I like to think I know what's going to happen. It's not a surprise every time when I do, but I hope when you guys do it, or the viewer, the listener, the reader, I hope when you do it, it is surprising and cool and fascinating. Back to you.
I thought that was a really cool concept that you said, that kind of kids making the world a better place, solving things with science. And it's really kind of neat. I think that the book captures some of these really big ideas in a really approachable way that makes it exciting for everyone. I actually really thought that was maybe my favorite part about it, was that I could relate to everything that was in the book, even though it's
Dr.
kind of my
Schmidt,
daily
I love
life.
you. Bring it on, Dr. Schmidt. Yes.
No, I was going to say, I think that you really hit on something there, that's actually, I think, when you're a kid, you're like thinking about what life would be like without parents. I feel like the further I've gotten into science, the more I want to go back to feeling like one of the, Jack and the Geniuses. Like, how do we make the world a better place? And how can I not forget that like fascination with science that I think we all have. So I thought that was really neat. And I think it does come across. It's a cool concept. And I guess, that's kind of inspiring too, because I think we sometimes don't realize how many young people are really doing these, having a real impact on science right now. And so I thought that was really pretty cool. And you hit on access to information, which is really great. And so I wondered if there's a favorite part that you have of the book that you guys would want to share, or what was particularly fun about writing it. Did you learn something in the process?
I learned something all the time because Greg was hustling and interviewed a whole bunch of scientists working in their fields right now. But the thing that's so wild, Brittany, Dr. Schmidt, is what's happening in what you might call astrobiology, or the search for life on other worlds. Because if we were to find evidence of life on other worlds, or if we were to find a way to make what you might call a self-replicating molecule or organized group of molecules, if we were able to find a way to do that, it would be profound. It would change the way everybody thinks about being a living thing and on the earth. And that search is almost certainly grounded, I guess that's a pun, that search almost always begins by looking at other planets, looking at the ground on other planets.
Now, one of the reasons we asked Dr. Schmidt to be here with us tonight is that we both, Bill works with her closely on the Planetary Society, and then I had the good fortune to write about her work a few years ago, and specifically her work focused on Europa, this moon of Jupiter. And I'd love to kind of steer the discussion. There it is. Steer the discussion over to astrobiology. But first, if you don't mind, I also want to point out that my first interview with Brittany was one of the strangest and coolest I've ever had, because I was trying to basically nail her down to this discussion, and she kept putting it off and saying, well, let's meet later. And I finally got it out of her that she was watching a Steelers game. The Pittsburgh Steelers were at a playoff game and she wanted to watch it. So I said, all right, well, can I just come watch it with you guys? And so then I watched the Pittsburgh Steelers game. I think they were playing the Packers, no, it must have been the Packers because it was a playoff. But anyway, we're sitting there watching NFL football, and she's talking about like plate tectonics on a different world and all this other stuff. And it was just one of the wildest discussions I've ever had. So, so let's steer in that direction. Let's talk a little bit about Europa and what you guys are thinking on that front.
Well, everybody, let's first understand what Europa is. Europa is a moon of Jupiter. And if you have a very small telescope, a starter telescope, or if you're some kind of steady with binoculars, you can see Europa. And so this is one of the moons that Galileo discovered. He took a military instrument, a telescope that they were using to look at the other army on the other hill, and pointed it at the sky. Apparently no one had thought to do that. Wow, really? Well, anyway, he wrote about it. Let's say that. He was the first guy to write about it that we know of. And you can see them move. These moons of Jupiter, Jupiter is so massive, and the moons are moving so fast that you can see them move over the course of a few hours. And one of them, Europa, like Europe with an A on the end, has twice as much ocean water as the Earth has. So if you have ocean water for 4.5 billion years, maybe there's something alive.
Yep, that is.
And how
that's
cool would that be? Yeah. And so, oh, by the way, if you guys are out there, be sure to send in your questions. Did we say that? We said at the beginning, but
yeah, send in questions. We'll be happy to answer them. But Bill, I loved what you said there. Also, because Galileo's like my favorite person, so I'm pretty lucky to get to like try to add up to what Galileo did. Just reread that paper this last year, actually writing a chapter about it. And
how long is it? How long is Galileo's paper?
You know, you were describing the observations. I actually have those actually here tattooed on my wrist. It's two different nights of the observations of Galileo. And it's a fun experiment. Actually, you were mentioning, you know, experiments you can do at home. If you have binoculars, take a binocular out. Actually, Jupiter is out in the night sky, by the way, right now. It sets around 10:15 Eastern. So if you went out after this talk, you'd have a great opportunity to try this yourself. But it's probably the second brightest thing in the sky right now. Mars is also pretty bright, but Jupiter's out. And if you took it and you put, you know, one hand over the other, over one of your binoculars, you basically have what Galileo used to observe it. And you just watch these little points of light, and that's what he really drew there, is these are the little points of light. And it was the first set of observations that anyone made that said something else is at the center of a system. And I thought that's just this concept that is real in astrobiology even today, that like the Earth isn't the only example, that we're not the center of the universe. It was a cool observation then 400 years ago, and it's just as cool now as we start to think about what can we learn from the Earth that tells us about the potential for life on other planets. And it takes us all over our own planet. It takes us across the solar system. It takes us thinking about, you know, exotic planets around other stars. And it's really a very, very powerful field. It's really inspiring, and it just kind of asks us to think big. And I think that was really kind of fun. And I'm glad that that made that point kind of was evident even over like yelling about football in a bar. So it's the kind of things that I think, you know, actually make us human, are these connections between us and what we think about. But yeah, Europa is this amazing place. And you know, I have a version of it here. You can see it's kind of spotty. It's got some red spots and some white spots. So it's this ice ocean moon. It has about 3 to 4 times as much water as the Earth does. And as Bill mentioned, it's been there for the whole story of the solar system, just as long as the Earth has. So it's had ocean water like the Earth. It might have had a seafloor. It may have that was active like the Earth's had. And so it's one of these like really important questions that kind of ties the history of the Earth and what we understand about it to the history of other planets. And we can ask these different questions of the different places, and that allows us to think about it.
So when you say active seafloor, you mean tectonic plates moving around? Is that what you mean?
Yeah, I just mean heat, actually, really. I mean any kind of heat. So if you think about planets, sometimes the way we think about them is that they're like a rudimentary battery, or like they're the thing that's powering up the life that lives on them. What makes the Earth special is that it's got all this geologic energy, and then life comes in and takes advantage of that, has water to help mix it around. But it's a really cool thing about the Earth. And places like Europa that have these lots of activity that look really interesting, like geology is still going on there. That's really something unique. And that's what we look for, is kind of like a planetary thermometer.
Dr. Schmidt, look at this question from Amanda Caldwell. I'm assuming the ocean of Europa is frozen, correct? Oh no, Amanda. Oh no, my friend. There's an icy shell, but underneath is liquid apparently salty water, like what the analog of seawater.
And
This is a big, huge idea. And so are there Europanians swimming around under the ice, talking Europanian, fish people doing Europanian things? And is their idea of the sky completely different from ours because it's ice and they don't see any stars? There you go. That's a great question, though.
Yeah.
That is a great question. And one of the points in the book, and we do have this whole chapter on astrobiology, and we kind of, first of all, I just have to say, I did talk to, I think, 75 different scientists for this book and try to get all their insight into what makes science important to them and why kids should be interested in it. But I'm sorry, I didn't talk to Dr. Schmidt for this one, and it sounds like it was a really bad idea because she's already had some awesome stuff to say. But one of the things that I thought was fascinating, and it's kind of a theme that runs throughout the book, when we're talking about evolution, when we're talking about planetary science, astrobiology, and the search for life, is time, right? It's one of these critical ingredients, is how long, these experiments or these demonstrations Bill has in the book, which is, by the way, available at Barnes & Noble. These are quick, you can do them at home. They're very simple, but this experiment that we call life that's running in the universe is billions and billions of years, right? I mean, explain that a little bit to us, please.
Yeah, I think I was just going to mention that, like, this is one of the things that we actually don't understand yet. We know it takes time, and we know our planet is so old and that the life on it has changed over time, but we don't really know how long it took to, like, cook the cake to begin with, right? Like, how long the planet was around before we actually had more than just the ingredients, but we'd kind of bake them all together so that you get life the way we experience it, and the way it could be different on other planets.
So the current number, you guys, the number everybody's throwing around right now is 3.7 billion years. That's the oldest living, or evidence rather, of the oldest living thing that's been found so far. 3.7 billion years. So I think what Greg is driving at is something I love to talk about. If you go to count to 1,000, 1, 2, 3, take you 20 minutes, 18 minutes, 17 minutes and something, 40 seconds. You can get to 1,000. If you want to count to 1,000,000 and you're staying up all night, okay, there's no sleeping. You're just going, you're just going for it for 11 and a half days to get to 1,000,000. When you turn 31 and 7 months, you'll pass through your your billionth second in your 31st year. If you want to count to 3.7 billion, not sleeping, we're awake, all we're doing is counting for over 117 years. You guys, the scale of 1 billion years, how much time is involved in 1 billion years is really hard to understand. It's really hard to get, but we did our best in here to give you something to think about. It's time, and more time with some time added. And by the way, try to come up with another word for time that isn't time. Like, we have afternoons, we have evening, we have morning, we have noontime, we have night. We got a lot of words around the idea of time, but the word time is almost magical. It just carries with it this something that we all have a sense of, but we really can't, it's hard to describe. However, people watching this right now are living at a time, see what I did there? Living at a time where it may be proven that time itself is divided into little packets, that time itself doesn't move smoothly the way, the way we think of it. And one of the symbols we used a lot in the book, Greg, where is one? One of the graphics we used a lot in the book was mind blown. My mind is blown. And that's where your head explodes, which it doesn't really, but it really is an astonishing thing.
No, we did have to Bill was surprisingly, so the book is full of graphics and drawings and diagrams with, whether it's about atoms or the way the ocean's heat moves around. And Bill was, to me, surprisingly, very detailed about the arrows and the diagrams.
Tenacious.
Tenacious, and with the mind blown. He really wanted to make sure it didn't look like this kid's head was literally exploding. It was very important.
By one example, yes, the graphics are really important, and the direction of the arrows on some of the maps are really important, or it doesn't make any sense. So this is a page about what causes oceans to circulate. And the reason you and I are able to breathe and live is because the ocean on the earth has motion. The ocean's moving around. It fertilizes living things in the sea.
All right. So, I was going to say, before we go on to questions, and I'm sure, Brittany, you might have a couple more questions, but I want to ask you two, and Europa can't be your answer, Brittany. What are your favorite worlds other than Earth? And Earth can't be an answer either, but there is no place like Earth, and we have a great chapter on our lovely planet. Yeah. What are your other favorite worlds?
So my favorite, actually, don't tell Europa, because Europa might be upset. I don't know. I don't know how Europa feels about me. I know how I feel about it. But my actual favorite planet is a moon, again. Moons are amazing. They're really underappreciated, but is Triton. So Triton is a moon of Neptune, but it's kind of amazing if you know the solar system and you just learned a little bit about Europa. It's kind of like Europa with Titan frozen out on top of it. So it's about the size of Europa. It's probably got an ocean underneath it, brand new surface with all kinds of weird stuff. It looks like a cantaloupe. And that's because of geology and heat and really cool stuff. And it has an atmosphere, and its atmosphere, though, it looks like Titan's atmosphere a lot, but it's mostly frozen out. And it turns out that this moon was also a Kuiper Belt object. So it's also Pluto. So it's like you take Europa, you take Pluto, and you take Titan, you put them in a blender, and then you put them on that page of the book, and it's orbiting Neptune because it got captured from its buddy 4 billion years ago, and it's just the most amazing place I've ever thought about. So I'm all Triton. Well, Bill, how about you?
I'm all hot for Mars. Mars is a world not too far away from our world, and it is reasonable. Mars is smaller than the Earth, so it cooled off faster. It got an ocean faster, it got an atmosphere faster than the Earth did. So it is, when we go to Mars and look around with our happy rovers and stuff, we realize that Mars used to be very wet. There used to be water all over the place on Mars. So it is reasonable. I mean, it's extraordinary, but it's not impossible that life started on Mars before it started on Earth. And life got going on Mars, but because Mars is smaller, it doesn't have the same magnetic field that the Earth does. And so the solar wind particles from the sun that are streaming off all the time over the last few billion years scraped the atmosphere of Mars off, a lot of it, not all of it, but a lot of it. And so there's really nothing living on the surface anymore. But what if there was? And what if we could find evidence of it, like fossil pond scum? And stranger still, what if under the sands of Mars, the very romantic idea, the sands of Mars, there's sand.
That's your next young adult romance novel, Under the Sands of Mars.
I love it.
Wow.
There's definitely a market for that.
Anyway, what if there's something still alive? Whoa, dude. And we could find it in my lifetime. So by the way, February 18th, 2021, everybody's on board. We're going to land another rover on Mars. So if you're asking me, Earth is number one, but Mars is of great interest. Mars is of great interest.
Very cool.
So kind of relating to that, actually, we got asked by Delbert Edward Mathis Jr., thanks for the question, said, do we truly believe there's life on a different planet? And I might steal that just to start off with it. there's two things there. One is that we don't really yet know what's possible until we go and look. And I think that's kind of a big mission for us. But the other thing is that we do know some parts of what's possible by looking at things here on the earth. And Bill's mentioned a couple of examples, but I wanted to show, like, my favorite example from the book actually is this picture of a tardigrade. I'm a big
Oh,
fan.
yes, Brittany,
So
yes.
tardigrade here, right there. So the tardigrades are like kind of everybody's favorite thing to think about, because they're these little organisms that can live through the craziest set of circumstances anyone can imagine. They can be frozen, they can be burned, they can be dehydrated, they can be sent to space, live through a vacuum. We haven't really thrown that much at them that they can't survive at some level. And so they're amazing. And so there's examples of plants and animals on this planet that surprise us, that make us think, wow, these are as close to aliens as I could even imagine. And so it's kind of that question. So I believe it would be a huge waste of space to, quote some of our favorite authors, not to have life on other planets, but it's less of a belief than a question and a pursuit. So I don't know if you guys have any comments or thoughts on that, Bill or Greg.
That you just hit the nail on the head. The word believe carries a lot with it, but it's certainly worth investigating. My goodness. And just when you get into this idea that there are at least 200 billion stars in our galaxy, and there's at least that many galaxies, if not 100 times that many galaxies, where you start to get into the 2 trillion thing, it just seems very, very unlikely that in all of that, there's nothing else alive. I mean, maybe. So you guys, I am so old. How old are you? I was at college in Ithaca at Cornell University when Frank Drake was there. And Frank Drake is this very well-known astronomer who created or came up with this thing everybody calls the Drake equation. And the Drake equation is a way of estimating, reasonably sitting around thinking, the back of an envelope, how many planets could support life. And so when I was in college, people would say to themselves, working with this estimation, they would say, well, let's say there's a planet around every 100 stars. In other words, you'd go through 99 stars and there'd be no planets, but on every 100th, there'd be a planet. Okay. Well, now people like Dr. Schmidt are pretty satisfied that there's 10 planets around every star. And so then you go from 200 billion times 100. Now you have 20 trillion planets. Like, dude, that's a lot of planets. And so if you have that many planets, it just seems like there should be something out there. But the question, as she said, the question is, do you believe it? Do you believe there's life elsewhere? Maybe. No, but yes. But it's a hypothesis. It's a question more than a belief. That's hit the nail on the head.
And I love one of the quotes we got from an astrobiologist. I think it was Michael Kipp at University of Washington, who said, you have to remember, though, that we're not looking for little green men. We're looking for the slimy, sludgy stuff that was around in the early days of the Earth. So we have another great question here that I want to jump to. But first, I just want to remind everyone, the book is Bill Nye's Great Big World of Science. Go out and grab it at your local Barnes & Noble or online 24/7. Oh yeah, Bill's very excited. It's a New York Times bestseller. I don't know if we're supposed to say that. But we have this awesome question here from Trent Perry, who's 6 years old. And Trent says he loves your show, Bill. And he's so excited that you're doing this book. He wants to be a scientist and an astronaut when he grows up. And he also wants to help fight climate change. What can he do now? Now, before I steer that question over to you guys, I want to say that is one of the themes of the book, is that, we don't want kids to think that science is something you're going to do when you're 20 years old or 25 years old. Science is something you can do right now, and every time I talk to a scientist, they talk about how they developed this passion and this curiosity at an early age. I think, Brittany, I think I remember you telling me it was literally just staring up at the stars at night in Arizona, right? Or something like that. So yeah, what can Trent, what can other kids like him do now?
Yeah, well, I mean, I'll jump in just for a second, just to say that one of the things that unites how we think about planets everywhere and our own planet is this importance of the system, right? The climate is all of the earth working together, and it's one way of looking at it. And so thinking about it is part of it, caring about it is part of it, listening to people is part of it, and then becoming a part of the story. I started as a planetary scientist, which means I learned a lot more about stars and planets and places far away before trying to figure out how ice worked brought me to Antarctica, and helped me get kind of a perspective on that. So it was kind of a neat way to think about or introduce me to how to think about climate change. It's some of the work that we do. And so whatever inspires you about it, whether you are a scientist or an astronaut like Trent wants to be, think about engineering, try these experiments at home, think about that, listen to as much information as you can, and then go build it. I was going to say that we actually build some robots in our lab. And when I say our lab, I mean my whole group is all grad students and undergrads, and even some high school students have helped us build robots that we've now taken to Antarctica to think about planets other places, but to also think about climate change and how to measure it and how to understand it. So it's a part that everyone can play, even high school students, even elementary school students. It is a role for everybody to play in trying to understand the climate and in trying to understand it and trying to make changes to how we handle it. So I would just say, keep asking that question and stay excited about it is the biggest thing, because everyone can have a role in that place.
So when I was in college, this professor, Carl Sagan, is a very well-known astronomer, talked about all the time, what he loved to talk about was comparative planetology, comparing one planet to another. And so the discovery of climate change on Earth in the last couple centuries was made really by looking at Venus. This guy, Jim Hansen, who was at something called the Goddard Institute for Space Studies, which is part of NASA. He was looking at Venus and realized that what happened on Venus is that makes Venus extraordinarily hot, too hot for anything that we can think of to be on the surface. It would melt the metal lead, would just turn to liquid on the surface of Venus. By studying that and then comparing that to Mars and then to the Earth, people realized the role of the atmosphere in keeping a planet like the Earth warm enough for us to be here. And you don't want to let it get too warm where it's going to be a hassle to be here. So what you can do as a 6-year-old about climate change is talk about it. If we were talking about climate change the way we talk about a whole bunch of other stuff, the way we talk about the Pittsburgh Steelers, for example, we would be doing a lot more about it. We would be getting on it. So I say all the time, hang on, Trent, I say all the time, if you want grown-ups to recycle plastic bottles, get their kids excited about recycling plastic bottles, and then you, Trent, will just hassle your parents till they recycle bottles. Yes. And so, Trent, if you start talking about climate change, let's say you get a copy of this book. I mean, I'm just jamming off the top of my head. If you got a copy of this book and read it and understood what we have to say about climate change and the process of scientific discovery that led to our understanding of it, you could be bringing it up enough so that your parents and your neighbors and everybody would get to work on it. And I say this all the time, Trent, I want you to keep this in mind. We need clean water, renewable electricity, and access to electronic information for everybody. These are giant, giant ideas, but we can solve them. We are going to solve them. You know, when I was a kid, when I was 6 years old, Trent, there were fewer than 3 billion people in the world. Now there are 7.7, almost 7.8. There'll be, by the time you're my age, there will be 9 billion. There might be 10 billion people, and we're going to feed them. We'll figure it out. But what we want to do is do it now, is get started on it now. We need better ways to move electricity around. We need better ways to get clean water to everybody, both to drink and cook, but also for our crops to raise our food. So if you want to do something amazing, Trent, figure out how to get salt out of seawater cheaply. We can do it right now. We do it all the time, but to do it inexpensively, that's a huge challenge. And Trent, if you can do that, of course, you'll save the world, and everybody will think you're great and all that, but also you might get rich, like crazy rich, like Bill Gates rich, and that would be cool. So think about that. That'll be either physics and chemistry and biology, or you'll be the attorney, the lawyer who figures out how the people who figure it out can get their patents and advance it. Or you'll be the person who goes to the communities and convinces people that really we can do this. This is worth doing. We're going to build this thing, and we're going to make it better, make the world better for everybody. You can go at it from any of these directions. But I just like people to keep in mind those three things: clean water, renewable electricity, access or able to get the internet everywhere in the world. So
no pressure,
cool
though.
Question.
No pressure.
Well,
yeah. And the book,
Greg, that was something you put in the book a lot, is you have, hey, solve this world problem and get back to us. That's very Greg Mone.
Yeah, and no pressure, guys. But the book is filled with a whole bunch of giant, enormous problems that we're ready for you to solve and figure out. And I love that point too, Bill, about kind of the different roles that we're going to need to solve these problems. So, even in our astrobiology chapter, Brittany, we talk about how we're not just going to need planetary scientists. We're going to need engineers to build the equipment that's going to go check out these worlds. We're going to need all kinds of help. Now, we have another great question here from Lex Hodges, who's in his 20s and wonders if this book is just for kids, or would people his own age or Lex's or her own age be interested too? So you literally cannot write a book like this if you're not interested in it. And I am obviously not a kid. Bill is not a kid. So this book, we like to say it's kind of for 8, or maybe with Trent here, 6, all the way up to 88 or so. If you're 89, I don't know, it might not catch your interest. But no, we definitely think it's all ages, and it's kind of, it covers so much that I think no matter what you're interested in, you're gonna find something that'll kind of like pique your curiosity.
So we had, when we started doing the Science Guys show, getting to be 30 years ago, you all, we had this research that by the time somebody's 10 years old, they have a person who's 10 years old has the ability to reason or think about the world or be logical the way grown-ups do, or what we think of as grown-ups do. The difference is the experience you have, and part of that is the words. Is by learning the words that we associate, in this case, in the case of this book, with science, learning the words of science, you start to get a framework or a way to organize your thinking that that enables you to learn more and more, faster and faster. And so in the book, my 20-year-old colleague, Lex, we have the words of science. I'm stumbling on words. The words of science, and they're described and explained. And it's a detail, but one that's very important to me, based on the years I've spent as an educator and this research that really got me going on it 30 years ago. So if you're 20 years old, Greg and I claim there's something in here. There's a lot in here for you.
I think it's, I had fun reading through it, actually. And there's parts that I'm an expert on that I think about every day. And there's parts that I was like, I had never thought about it that way, or that they were just kind of a good insight. And I think it gives you, it gives you a good way to talk about it. The conversation is part of the point, right? As you were mentioning, Bill, just how to talk to people about science and how to engage with it. I think it could be valuable for just about anybody.
And it's also, oh no, go ahead, Brittany.
Oh, I was just going to ask a different question, but please go for it, Greg.
No, I was just going to say the other piece, then the thread that kind of runs through it is just the importance, and this is speaking to the age issue again, is just the importance of continued curiosity, right? So we were talking earlier about little kids, and I have kids right in this age range, and it's easy to get them excited about science, and especially the stars. You go out and you look at the stars and you say, hey, there could be some Earth-like planets, you know, spinning around that, orbiting around that star up there. And it's just boom, you know. What disappoints me is when we start to lose some of that curiosity and that sort of like that appetite for these big grand questions and that willingness to have your mind changed as new ideas come in. So that's kind of a thread that runs through the book as well, because every scientist I talk to, you know, that was one of my favorite things. It was never, you know, I'd ask, what do you need to be a great scientist? No one ever said you have to be intelligent. Everyone said you have to be curious. And that is the key, right? I mean, does that feel right?
Absolutely. It's one of the things that I love about teaching is that you get to think about it, and you have to think about it from a different perspective every time. It's one of the cool things about this conversation, right? Is that we get to try to wrap our heads around science and how we each think about it. And yeah, absolutely. It's really about just wanting to keep it going.
So along this line, I am very proud of the introduction. Oh, by the way, there's one of the periodic tables that appeared on the old Science Guy show, still in service here at Nye Labs, still on the wall even now. Is this idea that some people are very troubled by not knowing the whole story of the universe, by not knowing where we all came from, by not knowing whether or not there's living things, whether or not there are living things elsewhere. Some people are just really bothered by that. But I claim if you're curious, if you're wondering about it, how can it not be the coolest thing ever? Yeah, we don't know everything. Isn't that cool? Now we got something to do all day. Come on. If we knew everything, what would it even matter? No, it's just, this is what has driven us forward. And you compare, Brittany was showing us her crazy tattoo of Galileo's sketches. It's not crazy. It's cool and wonderful. Her wonderful tattoo about Galileo's sketches. Just think how far we've come in 400 years from when Galileo made these discoveries, just sort of stopping and thinking, using a so-called military instrument, a telescope. Just, oh, I never tried this. Whoa, at night, cool, wow. Anyway, except it was speaking Italian, understand. Just think what is ahead. You know, something we talk about at the end of the book that's really important is you talk to astrophysicists or astronomers or Brittany or whoever it is, and ask them about this thing that right now is being called dark matter. So you either get one of these three numbers, 94%, 95%, or 96%. 96% of the universe, we don't know what it is. We don't know what it is. It's dark matter. It has gravity. It's pulling things around. Nobody can see it. It's dark. Yeah. Okay. And so in my grandparents, when they were born and when they were in high school and stuff, they didn't know anything about relativity, the discovery made by Albert Einstein. They didn't know anything about it. It didn't affect their lives. They just carried on. It's all good. Okay. But then when they got to be parents and then grandparents, they saw nuclear weapons, nuclear energy, the discovery of the neutron, for example, inside of atoms. Just think what we may discover in the next 30 years. And 2 weeks ago, Nobel Prizes were issued to people, to Jennifer Doudna, who discovered a way for something like a virus molecule, a protein, to go along DNA in a cell and find a specific place and exchange one thing for another, all naturally, all using living things. So this is going to change the course of history, you guys. We're going to be able to make, I was talking about feeding everybody earlier, we're going to be able to make crops, plant corn, soybeans, something or other that grow much better than they grow now. They use less water. They can grow in dry conditions. They can grow in flood. We're going to be able to do all these extraordinary things because the discovery that was made 10 years ago, Nobel Prize was, or 8 years ago, and the Nobel Prize was issued 2 weeks ago. It's like the most exciting time ever. And this is what has been said a few times, you guys, is if you couldn't pick where on Earth you were going to be born, there's some rule, some science fiction rule. You couldn't pick where you were going to be born, but you were somehow allowed to pick when you were going to be born. This would be the time. This is it. This is the most exciting time in human history. They're as screwed up as things might seem to be with wars you hear about and crime and water problems with the sewer, with the water mains in Atlanta or whatever it is, all those sort of problems you hear about, there are actually fewer problems. The world is actually better for more people than it's ever been. And that's where the young people who I hope are going to read this book are going to change the world. Back to you guys.
So we're running out of time here. I want to thank Barnes and Noble for having us. I'll leave it to Brittany and Bill to say one last thing. I want to thank Barnes and Noble for having us again. The book is Bill Nye's Great Big World of Science. It's available at your local Barnes and Noble, but there are limited copies, so you might need to run out and get one. Not now because it's late, but it's also available online 24/7. Thank you, Brittany, so much for joining us. This was fascinating to hear you talk about science in general and astrobiology in particular. Bill, amazing as always. Thank you both. And I don't know, leave you guys with the last word.
Well, just thanks again, Greg, for all your help with the book. He interviewed all these people. He proofread everything. He asked question upon question. Oh, man. So thank you, man. And Brittany, thanks for taking the time. And by the way, you all, there's one last question. How cold is space? My grandparents probably really wouldn't have had any idea how cold the space is, but now we'll tell you. It's 3 degrees Celsius, what we call 3 kelvins, above absolute zero. That's what it is. We know that.
Jameson, it is cold, right, Brittany?
It's cold.
It's pretty cold. Yeah. No, it's really great. Guys, thank you so much. This was a lot of fun, and congratulations on the book. What an exciting achievement. And it was really just a wonderful break from the week to get to hang out and talk about it. And congrats again.
All right, you guys, thank you so much. And I'm not kidding. I want the readers of the book to go out there and, dare I say it, change the world.